As we have discussed in your previous session, in order to calculate the electrode potential of an unknown electrode, you have to know two things. One is your She with reference to one electrode, that is your She, that we have discussed in your previous session. The other thing, as I have told you, you have to know about what do you mean by EMF or cell potential. What do you mean by EMF or cell potential? The full form of EMF is electromotive force. So let us see what is this EMF or cell potential. It means one and the same. So let us see what is this EMF or cell potential. Whenever you set up a cell, you remember the two half cells in that. That is an oxidation half cell and a reduction half cell. The cell in a cell, when you set up a cell, the electrode potential of one of the half cell will be lower than the other half cell. So as a result, the electrons will flow from one half cell to another half cell. That is, it will be flowing from the electrode potential, that is the half cell with lower electrode potential to the half cell with higher electrode potential, which means that the two half cells have a difference in electrode potentials. This difference in electrode potential of two half cells in a cell is called as your cell potential. Very simple. So it is the difference between the electrode potentials of two half cells in a cell. Two half cells are oxidation half cell and reduction half cell is called as your cell potential. So I can define it as cell potential as it is the difference in electrode potential of two half cells in a cell. Remember, two half cells are oxidation and reduction half cell. So the difference in electrode potentials of two half cells in a cell is called as your cell potential. It is symbolized by E cell. Which means that the two half cells have different electrode potentials. And remember, the electron always flows from the half cell having higher potential to lower potential. So electrons always flow from the half cell with higher potential to lower potential. So electrons always flow from the half cell with higher potential to the half cell with lower potential. So this difference in electrode potentials between the two half cells is called as your cell potential, and it is represented by E cell. The E cell, that is your EMF or cell potential of a cell, can be determined by using an equation, that is E cell is equal to E, that is electrode potential of cathode minus electrode potential of anode. EMF of the cell, that is E cell, is equal to E cathode minus E anode. This is the representation in order to calculate your E cell, that is the cell potential of a particular cell. It is E cathode, electrode potential of cathode minus electrode potential of anode. Or I can also write it as E cell is equal to E cathode. Where is cathode present? It is present on the right hand side. Anode. Where is anode present? Anode is present on the left hand side. So I can write it as E right minus E left. You can also write it as E right. That is the electrode potential of the right hand side electrode minus electrode potential of the left hand side electrode. Or you can also write it as E cell is equal to right side cathode. What is happening? Reduction is happening. Left side anode. What is happening? Oxidation is happening. So I can write it as E reduction minus E oxidation. E oxidation. So these are the three things you can find in different textbooks which means one and the same. That is E cathode minus anode, or E right, because cathode is present on right side, anode is present on left side. E right minus E left. E reduction, right side reduction happens, so E reduction minus E oxidation. So these are the three different things which means one and the same, which tells you, which helps you in calculating the cell potential. So if I want to tell you the standard cell potential is nothing but the cell potential at standard conditions, that is the 1 molar concentration as well as your temperature at 298 Kelvin. If I want to tell it in standard conditions, it becomes E naught cell is equal to E naught reduction minus E naught oxidation. E naught oxidation. So standard electrode potential of reduction, that is standard reduction electrode potential minus standard oxidation, that is your electrode potential at oxidation half cell. So standard conditions, if you want you can write this. So this is for your standard conditions and this is for your normal condition. E cell is equal to E cathode minus E anode, or E naught cell is equal to E reduction minus oxidation, the same thing. The opposite thing, that is the, you can write this as cathode minus anode. And here the electrode potential which I am speaking here, all these things, that is the electrode potential of the cell is equal to electrode potential of standard electrode potential of cathode and standard electrode potential of anode. All these electrode potentials here I am talking, they are your reduction potentials. Reduction potentials. Potential. I have told you there are two types of potentials, electrode potential. One is reduction potential and your oxidation potentials. So all these things which I have written here, electrode potentials, are your reduction potentials and they are not your oxidation potentials. I am mentioning this because in some textbook you can also see that E cell is equal to E anode plus E cathode. So as a result I am telling you that this is your reduction potential I have considered in this. More precisely I will be telling in my further videos what is the difference in this reduction potential and oxidation potential. But remember, if you want to use this formula, the reduction potentials of the respective electrode should be given. What should you do for your oxidation potential we will be seeing further. But remember, all these things which I have taken, these are your reduction potentials. These are your reduction potentials. So now we have studied about the two things also. That is, what is She, how to use it, as well as what is EMF of a cell. Now let us see how to, that is your session 8th things, that is session 9th thing, that is how to calculate the electrode potential of an unknown. So let us take an unknown thing, that is zinc rod. Let us take this as a zinc rod. So this is a zinc rod dipped in zinc sulfate solution. So this is your zinc rod dipped in zinc sulfate solution. Okay. I don't know its electrode potential. I don't know whether it is undergoing oxidation or reduction. You know, but you have to imagine that we don't know what is happening at this electrode, that is half cell. What is this half cell? Whether it is undergoing oxidation or reduction. Now using She, I have to find out whether this is undergoing oxidation or reduction. How to find it out? Let us see. This you have to connect it to a voltmeter or an ammeter, which is further connected to a She. So we don't know, this is an unknown, its electrode potential is unknown, whether it is undergoing reduction, oxidation is also unknown. Just I have connected to a She, that is a standard hydrogen electrode, reference electrode with the voltmeter. Obviously I have to connect it internally also through your salt bridge. This is your salt bridge. The two things unknown is, here we don't know whether reduction is happening or oxidation is happening. What's the value of electrode potential of this zinc? We don't know. The first thing, that is whether it is oxidation or reduction. If you observe the flow of current, direction of current, you can observe the flow of current, direction of current, it is in this way. This is the direction of current. You can observe this, where is the current flowing? It is flowing from she to this half cell, which means that electron is flowing in opposite direction. Electron is flowing in opposite direction. That's nothing but your conventional current. So if you observe which is the direction of the current, we can tell which is the direction of the electron flow. In this situation, the current is flowing from she to zinc rod. Hence, we can tell that electron is flowing from zinc to she, which means that zinc is undergoing oxidation. It is giving electrons, means zinc is undergoing oxidation. The first problem is solved. We know that zinc is now undergoing oxidation. So zinc is undergoing oxidation. Zn2 plus 2 electrons. So by knowing the direction of flow of current, you can identify whether your half cell is undergoing reduction or oxidation. Since it is undergoing oxidation, we have to now find out the oxidation potential, that is the electrode potential of zinc rod. How to find it out? Very simple, we know that E naught of she is 0. We know this. We already know that E naught of she is 0. You can calculate the E naught of cell, that is E naught of cell, you can get it from this voltmeter, E naught of cell. E naught of cell measured was equal to, that is the E naught of cell, that is the cell potential measured from this cell, it was equal to E naught of cell measured, it is measured through the experiment done through the cell, the E naught of cell measured was equal to plus 0.76 volt. E naught of she is already known, it is 0. E cell is measured from the cell, that is using the voltmeter, it is plus 0.76 volt. Now we know the equation, E naught of cell is equal to E naught cathode minus E naught anode. Which is the cathode? Cathode is she, because it is on the right hand side, it is undergoing reduction. So as a result, E naught of cathode is 0, because we know that E naught of she is your cathode, it is 0, minus E naught of anode, that is E cell. What is E cell? E cell is measured, it is 0.76 volts. Therefore, E naught of anode, it is equal to, if I cross multiply your minus, it becomes minus 0.76 volt. This is your E naught of anode. What is the anode? Anode is your zinc. So it becomes E naught of zinc 2 plus, oxidation is happening, Zn2 plus, it is equal to minus 0.76 volt. So this is the electrode potential of zinc. In the same way, you can make it for copper also. Just connect your copper rod dipped in copper sulfate solution to she. You can observe the opposite direction current is flowing, that is, it is flowing from copper to she, which means that electrons are flowing from she to copper. As a result, if you get the values, you can calculate in the same way for your copper also. So if you connect a copper rod, that is copper dipped in copper sulfate solution to she, you can observe current flow is from copper rod to she, which means that electron is flowing from she to copper, which means that copper is undergoing oxidation. Electrons are coming from she. Hence it is a cathode, so it is undergoing reduction. Cu2 plus 2 electrons give rise to Cu. It is undergoing reduction. So E naught of she is 0. E naught of cell measured was, for this one, copper rod, E naught of cell measured was, it is 0.34 volt, sorry, 0.34 volts. So now calculate your E naught cell. E naught cell is equal to E cathode, E naught cathode minus E naught anode, anode. E naught cell is equal to, sorry, E naught cell value you can write it out directly. It is 0.34 volts. It is equal to E naught cathode. E naught cathode is unknown. Anode. Anode is your She now. This is your anode now. So anode is, we know that it is 0. So this is E cathode, sorry, E naught cathode minus 0. 0 because now She is acting as anode. Copper rod is acting as your cathode. That is, electron flow shows you that this is your anode and this is your cathode. Therefore, E naught cathode becomes equal to 0.34 volts. That is, E naught of Cu2 plus Cu, reduction is happening, it is equal to 0.34 volts. So like this, by connecting your unknown electrode through She, by knowing the current flow direction, you can calculate your E naught of different electrodes whose electrode potential is unknown. Let us take a numerical based thing, that is numericals. To calculate the E naught cell, that is the standard cell potential of a Daniell cell. Let us take a Daniell cell first. So we know Daniell cell representation, that is Zn to Zn2 plus Cu where zinc and copper's electrode potential, standard electrode potentials are given. E naught of Zn, it is equal to minus 0.76 volts given, this is given, E naught of copper, it is equal to plus 0.34 volts. You have to calculate E naught cell. You have to calculate E naught cell. This is your Daniell cell. Remember, it is your Daniell cell. You have to calculate E naught cell. What is the formula? We know that E naught cell is equal to E naught cathode minus E naught anode, or E cell, we know that E naught cell, that is cell potential, is equal to E naught cathode, standard electrode potential of cathode, minus E naught anode, standard electrode potential of your anode. Or you can also write it as E right minus E left, or you can also write it as E reduction minus E oxidation also. E naught reduction minus E naught oxidation also. So let us see what is cathode now. In the cell representation, we can see that copper is your cathode. So copper, the electrode potential is plus 0.34. So it is plus 0.34 volts minus E anode, which is anode. Anode is your zinc. Zinc is your anode. What is the electrode potential? It is minus 0.76 volts. So this becomes equal to the E naught of cell, that is Daniell cell, is equal to approximately 1.0 volts. So this will be the cell potential, as I have also told you in your Daniell cell. It is the cell potential of Daniell cell, it is equal to 1.0 volts.